Claude Opus 4.6 update just dropped, and it may have fundamentally changed the AI agent game. 16 autonomous agents worked in coordinated parallel for 2 straight weeks, producing a fully functional C compiler with more than 100,000 lines of Rust code, without a single human writing the core implementation. The result wasn't a toy project or a proof of concept. It can build the Linux kernel across 3 different architectures, passes 99% of a specialized compiler torture test suite designed to break fragile systems, compiles Postgres, and handles other large-scale real-world software. The total cost of the entire effort was roughly $20,000, a fraction of what equivalent human labor would require. Just 1 year ago, autonomous AI coding would lose coherence after barely 30 minutes. 30 minutes. Now we're looking at 14 uninterrupted days of sustained engineering. That's not incremental progress or a smooth upward curve. That's a phase transition. The baseline just moved and the world shifted with it. To understand why this feels so different, you have to look beyond the headline number of a 1 million token context window and focus on what actually changed underneath the surface. Opus 4.6 expanded its context from 200,000 tokens to 1 million, which means it can now hold roughly 50,000 lines of code in a single session, up from about 10,000 in Opus 4.5. On paper, that sounds like a simple scaling improvement. But raw size isn't the real breakthrough. The real breakthrough is retrieval. A massive context window is meaningless if the model cannot reliably locate, extract, and apply the exact piece of information it needs at the right moment. Earlier models could technically ingest huge volumes of text or code, but once that information was buried deep inside the window, retrieving the correct detail became inconsistent and often unreliable. It was like having a giant archive with no dependable indexing system. Opus 4.6 dramatically improves its ability to navigate that space, to pinpoint relevant functions, dependencies, or definitions, and to reason across them coherently. In effect, it transforms the context window from passive storage into something much closer to active working memory. And that shift, from holding information to dynamically reasoning across it, is what makes sustained, system-level understanding and long-duration autonomous work possible. The compiler story was impressive, but what may matter even more is what happened inside Rakuten, the Japanese e-commerce and fintech giant, when they deployed Opus 4.6 directly into their live engineering workflow. This wasn't a polished demo or a controlled lab experiment. The model was integrated into real production systems, connected to active issue trackers, spanning 6 separate code repositories, and a team of 50 working developers. In a single day, the AI autonomously closed 13 issues on its own, correctly assigned 12 additional tickets to the appropriate engineers, and escalated more complex or ambiguous cases to humans when judgment was required. It wasn't simply generating patches. It demonstrated an understanding of repository ownership, subsystem boundaries, and individual developer context, recognizing which teams were responsible for which components and how changes in one area might affect another. In other words, it understood not just the code base, but the organizational structure wrapped around that code base. That's not merely technical intelligence, that's operational coordination at scale. And when an AI system can handle ticket triage, work routing, and dependency tracking across 50 engineers in a live environment, you're no longer describing a coding assistant. You're witnessing the early automation of core management functions that traditionally sit at the heart of engineering leadership. What may ultimately matter more than the compiler or the enterprise deployment is what happened when Opus 4.6 was directed towards security research. Armed with nothing more than standard developer tools and access to a large open-source code base, the model began systematically probing for weaknesses and ultimately uncovered more than 500 high-severity zero-day vulnerabilities that had gone undetected despite prior human audits and automated security scans. These were not trivial bugs. They were critical flaws requiring immediate fixes. Crucially, the model was not given a predefined detection strategy or a curated list of targets. When initial surface-level analysis failed to reveal deeper issues, it independently shifted approaches, diving into years of commit history to understand how the system evolved over time and where architectural decisions may have introduced subtle risk. It reasoned not only about the static structure of the code, but about the timeline of its development, tracking how patches were applied, where assumptions changed, and where security-relevant modifications might have been incomplete or rushed. In doing so, it constructed an internal model of data flow, trust boundaries, and fragile dependencies across the system. That combination of extended working memory, temporal reasoning, and adaptive strategy is what enabled it to uncover vulnerabilities that traditional tools and experienced researchers had overlooked. The introduction of agent swarms in Opus 4.6 may be the clearest signal yet that AI systems are beginning to mirror the structural patterns of human organizations. Instead of relying on a single monolithic model attempting to handle everything sequentially, multiple agents now operate concurrently, each assigned a distinct role and working within its own dedicated context window. A designated lead agent decomposes overarching goals into structured tasks, assigns them to specialists, manages dependencies, and monitors progress across the system. Meanwhile, specialist agents execute independently, communicating directly with one another when coordination is required, while a shared task framework tracks work as it moves from pending to in progress to completed. This isn't merely a productivity enhancement layered on top of an existing model. It represents a deeper architectural shift that echoes how complex work is organized in the real world. Humans didn't invent management as a cultural preference. They developed it as a structural necessity for coordinating intelligent actors at scale. The fact that AI systems naturally converge toward similar hierarchical and communication patterns suggests that management itself is not uniquely human, but an emergent property of large-scale coordination. And now, for the first time, that structure is embedded directly within the model's operational design. If you extend this trajectory forward, the implications become even more dramatic. Prominent AI leaders are openly predicting that a billion-dollar company founded by a single individual could emerge within the next year or two, not because that founder suddenly works harder or longer hours, but because they command a coordinated network of agents capable of sustained autonomous production at scale. When one skilled operator can orchestrate dozens of AI systems, running continuously, refining, iterating, and shipping around the clock, the traditional relationship between scale and headcount begins to unravel. The constraint shifts away from labor capacity and toward clarity of vision and decision-making. Instead of assembling a team of 20 engineers to build a product over 18 months, 3 humans with strong judgment and domain expertise can guide agent teams to deliver comparable systems in a fraction of the time. The strategic question for leaders is no longer simply how many people to hire, but how many agents each person can effectively direct. What workflows maximize that leverage, and which uniquely human skills, taste, prioritization, ethical judgment, must be strengthened to ensure that this multiplied capability is used responsibly and intelligently. Project the current curve forward and the tension becomes impossible to ignore. 2 weeks of autonomous engineering already feels extraordinary. Yet just a few months ago, even sustaining a few hours of coherent, independent work seemed out of reach. If that acceleration continues at anything close to its current rate, sustained agent operations lasting months could soon become routine rather than remarkable, enabling AI systems to design, build, test, document, and deploy complex applications with minimal human interruption. That level of persistence fundamentally reshapes how we think about planning cycles, project timelines, and competitive advantage. Organizations capable of running coordinated agent swarms continuously will iterate faster and compound improvements more rapidly than those still structured around human sprint cadences and meeting cycles. The massive surge in hyperscale infrastructure investment begins to make sense in this context, as companies prepare for a world in which millions of autonomous agents operate simultaneously across industries and enterprises. The real question is no longer whether agents will scale. It is how quickly institutions, leadership models, and workforce structures can adapt to a reality where software development, research, and operational coordination no longer pause at the end of the workday. It's easy to feel overwhelmed by how fast this is moving, but the most practical response is surprisingly simple. Touch the tools every month. Don't anchor yourself to what you learned in January or even what worked last quarter. Open the newest system as soon as it launches. Experiment with it deliberately. Push it on real tasks that matter to your work, and pay close attention to where it surpasses your expectations and where it still struggles. That gap between what you assume and what it can actually do is where your outdated mental model lives. Each month now represents a meaningful shift in capability, and staying current is no longer optional. It's becoming part of professional survival and knowledge work. The pace may feel relentless, even disorienting, but ignoring it will not slow it down. The future of work is steadily shifting from operating tools to directing autonomous agents, and the sooner you internalize that transition, the more agency you preserve in shaping your role, your leverage, and your relevance within it. This is where we are. Autonomous agents coordinating in structured teams, executing complex projects for weeks at a time, reasoning across massive code bases, managing workflows, and scaling output beyond what traditional human bandwidth alone could sustain. Just 8 weeks ago, much of this would have sounded speculative, maybe even exaggerated. Today, it's operational. Tomorrow, it will feel routine. The direction of travel is unmistakable, even if the final destination remains uncertain. As sustained autonomy improves, the distance between idea and execution continues to compress, and the architecture of knowledge work keeps evolving in response. Planning cycles shorten, iteration speeds increase, and leverage multiplies. The question is no longer whether AI agents will shape the next phase of work and organizational design. They already are shaping it in real time. The deeper question is how we choose to position ourselves within that shift, not as passive observers reacting to headlines, but as informed participants learning to operate effectively inside a rapidly accelerating system.